So this is very brief list of the data available for textual analysis. So earlier we are using income statement, balance sheet, but right now we can have the press release, proxy statement, all the CEO compensation contract is in the proxy statement, and also a lot of audit information in the proxy statement as well. And I use the social media conference call, and also I use the IP address, and I use news. So there's a lot of accounting information. So I define accounting information very broadly. Anything goes to SEC filing, I feel this is part of accounting information. So some even a conference call, and also so these are the, I call it disclosure, because these are the information firms has to file to SEC, and we can use all this for textual analysis. So I discussed about this last time, so I'm not going to spend too much time on this since we discussed about the last class. And so I want to start with the keyword search. So for textual analysis, when you guys see right now 90–80% of the staff doing keyword search. When you ask me whether you should do keyword search or not, I would say, why not? I mean, if keyword search can address your research question, I really think this is a simple step and easy, low cost, but you will always get pushback from referee on this. And that time you can start some more fancy stuff. But keyword search, I would say it's good. But let's see how to do keyword search, and also what's the limitation of keyword search, because when people challenge you, you can address that limitation. And so of course we know that advanced is easy, right? Easy to implement. So there's some cost of that too, limitation too. So first, the keyword search by terminology, easy, just count the frequency. So let's say sentiment. So what people do is you count the positive words of the sentiment, and you count the negative words of the sentiment, and then use the negative words frequency minus positive word frequency. You divide it by the total length of the document, and that gives you the sentiment score. So that's very straightforward, right? Very straightforward. Okay, so there's a couple of things we want to talk about today. First is sentiment. So many people are doing, so you don't want to do sentiment. You want to do something new. So for example, CSR, for example, AI, for example, something labor market, or something in household finance, you want to do Fintech. So you want to create your own keyword list. So here's the challenge. How did you get the list? So because the sentiment list, Tim McDonald, they created for you, and you can use it, you can cite it. But if you want to do your own research, you want to have your own keyword list. So how we create a keyword list, that's the number one thing we want to discuss about using this simple methodology. And number two thing is what's the limitation? Like what people will question you on this? Like what's the downside of using the keyword search? So I listed 5 ways to create a keyword list. So first of all, there's some keyword lists available on the literature. So if you want to do ability, there's an ability keyword list. So you want to do cache, there's a cache keyword list. The sentiment, you want to do forward-looking, there's forward-looking keyword list. So you want to do the deceptive keyword list, readability, so uncertainty, performance, product. So these are the keyword lists available in the literature. So for this one, easiest way, you just cite them and you just use them. And most of them, they are make it available in the draft, because most of appendix, they will put that. And if you can find them, you can let me know. I can send you the reference. The problem with that is, first, many of the papers are not published. Like sentiment is well published in JF, and people take it. But a lot of keyword lists here are still working paper. So if you use them, of course, they feel happy. You cite them, but at the same time, how well established are these keyword lists? Maybe a problem. But I think it's a beginning step, and it's an easy step if you use the existing keywords to measure your stuff. Like I said, if you are interested in culture, there's a culture keywords there as well. And this is the number one you can do, use the keywords available. So today we have 2 papers discussed. I created my own keyword list, and one keyword list is existing, but the other keyword list I created my own because there's no keyword list available for that. So we can later on we'll discuss about how exactly the keyword list was created. But here I just want to give a roadmap. Like there's five ways to create your own keyword list. So the first way is actually related to Michael's earlier point. You read a small sample and then you pick up the keyword on your own, and you can say that's the keyword list relevant to your subject. So for example, the team McDonald, what they read is, I think they read 5% of the sample. I forgot exactly how much they read, but they read it, then they kind of sense what are the words which is positive, what are words is negative. They manually pick them up. And after picking up, they say, okay, that's the keyword list. They think that's the right keyword list. And then the next step is validation. So once the positive keyword list, they want to show that it's positively correlated with market reaction. The negative keyword list will be negative correlated with market reaction. And then so that they establish the keyword list, and you can cite them and use them. So one is read on your own, using a small sample, read on your own. But this methodology, I think, if your paper is, if textual analysis is main part of the paper, I think it will work. But if the main part of the paper is textual analysis, people will question your subjectivity. If you think, okay, you read this is a keyword list, I read maybe this different keyword list. So I would say this is a good approach, easy approach. I always prefer easy approach. But if your whole paper is about textual analysis, this one, I mean, you may have some work during the R&R process to redo the keyword list. But this is a good approach. I would recommend. Okay, so another approach I would also recommend. I always prefer easy one. That's why I put the easy one first and put the more complicated one later on, because I told you guys first day class, like I start from easy. I just feel things become more complicated unexpectedly, and I can imagine if I start with a complicated model, later on how complicated it can become. So I always want to start with easy stuff, and don't worry about the complication. Don't worry about your model is not sophisticated. People will push you. People will push you to the sophisticated side. So the second approach, I love it because it's simple, plain, and it's save time. It's called a Corpus approach. So what does it mean is, so I give you an example of the political keyword list. So with the political keyword list, so what they do is, so they get the political textbook, using the keyword in the political textbook as the keyword list for the political keyword list. So this is a very, like I said, simple approach because textbook is already there, and you use the political keyword list. They have a lot of index, political words, terminology, so you can get the list of a political keyword list ready for your analysis. But there's some problem there, which is a political keyword list not just have political. They have economics, they have accounting, they have so many other stuff. If you just use the words, keywords from political textbook, you can get a lot of non-political keywords from political textbook. So what we people do is you use the political textbook minus other textbook. So for example, you believe the political textbook has a lot of accounting information, accounting terms, which is unrelated to your question. You use the political textbook minus the accounting textbook. And you think there's a lot of medical terms in the book, and you minus medical book. So basically you want to get you use the subject you want minus other textbook, which is you don't want them to be included in your keyword list. So people use that approach to get the keyword list. Like I said, it's still a lot of noise because even you minus medical textbook or accounting textbook, you still have some unrelated words. But you can. What else you can do is you can sort the keyword by frequency. The most highly appeared keywords in the political textbook will be the political keyword list. So there's a ways to refine the keyword list. But I like the approach because this is relatively easy compared to the later part. Because if I explain later part, you involve a lot of. The room is kind of cold. So yeah, so that's the So using the textbook, of the subject of interest, so minus something else you are not interested. This is another way to build keywords, which I would say you can check it out. We will talk more about that along the semester. And so another approach is a dictionary approach. So the dictionary approach is what you do is there's a available dictionary on each subject. So if you look at the Oxford dictionary, they are online. They have each subject. So for example, risk. They give you a word similar to risk online. So they already define that online. So you find risk is about 50 words similar to risk. So you can use that as a keyword. But so that's also ready to use. So the first three approach is what I say is the first approach you need to read on your own. The second approach, use textbook. The third approach, using the similar words defined by the well-defined textbook. So these are all ways to establish the keyword list. That's the first step to on your own subject. So today we are going to talk about using unsupervised way to expand the keyword list. So what does that mean? I just give you a very brief idea. What does that mean? And then later on, when we talk about the paper, we can get a concrete idea how to do that. So this approach is what do we do is you first define a seed keyword list. So for example, climate. I put a lot of a climate paper for you guys because I feel this is a good space for do textual analysis. And so let's say you want to define what is the climate related keywords. So of course you know the carbon emission, right? You know the carbon emission. You know the alternative energy, right? You know the green energy. So these are the keywords for sure they are related to climate. They are related to climate. You are for sure. Okay, but this list is not comprehensive. What we need is a comprehensive list of all the climate related. So you can go to the Oxford dictionary, but even the Oxford dictionary is not complete because they update every year. Like the climate is so changing so rapidly. There's not so many words, and their word list is short. It's 50 words, 20 words. So you want a comprehensive climate-related keyword list. So what you need to do is you define very short climate keyword list, like I said, and then you use machine learning to expand the keyword list until we think the keyword list become the most comprehensive climate keyword list. That's the procedure we are doing. That's the procedure we are going to talk about today. So basically, you start from something for sure, seed keywords, and then we use machine learning to expand the seed words until you reach the point that you feel the machine has included all climate-related keyword lists. And if we include more, it will become unrelated. Until we reach that point, then you have built a complete list of climate-related keyword lists. So that's like I said, that needs some little bit of work compared to the earlier part. But the rewarding is it's comprehensive, it's technology backed, and that's the rewarding part. The cost part is involves some work we do, and this is popular. This one is popular, and a lot of people are doing that. Not just me, a lot of people are doing that. Okay, so the latest one we call the supervised. So it's supposed to be self-supervised. So self-supervised is, for example, I'll give you an example. For example, sentiment. If we do one way is human read it to get the positive words and negative words, to get the words related to positive and negative. So the supervised way is what we use supervised machine learning to have machine to pick up the words by machine instead of by human. So that's what we call the self-supervised. It's self-supervised. So compared to the first approach, human pick up the positive words and negative words. we have a machine to pick up positive words and negative words for you by machine instead of by human. But for that part, what you need is you need a label for this one. So let me give you an example. So for example, sentiment. So what people do is all the words in the data is the input, and you train a model, and then the label is the return. So any words is a positive associated with the positive return will be positive keywords. Any words associated with negative stock returns will be negative keywords. So that's how you can use this self-supervised machine learning to get the positive keywords and negative keywords. But the constraint here is you need to know the return. You have the return to help you to pick up what the positive words and negative words. But in a lot of research, you don't have that label. Here you can observe the return as a label for you to train the positive and negative words. But a lot of cases, you don't see the outcome. You don't see the labels. So if that's the case, you have to rely on human. So human has to label them first, and then we learn from human. So that's normally we do. But if you have variable like returns, and you can just use the returns to train the positive and negative words. But if you don't have variable like returns, and you have to rely on the human to pick up. Once human pick them up, we can build a model to mimic human intelligence of picking up these words. So that's difference with self-supervised and supervised. So self-supervised is you use the existing label to train a machine learning model. And the supervised is human train it first, and then you mimic a human's intelligence of picking up the task. That's supervised. And the unsupervised is there's no labels, there's no outcome, there's no objective function. It's just clustering. You just get the similar stuff together. It's just grouping. That's unsupervised. So here we talk about three concepts of the machine learning. Here is like of course the easiest one is self-supervised, because self-supervised you use the existing label to train a model. You don't have to. There's no human involvement in that. You just use existing labels to train the model. I always prefer that, but the world is not that perfect. Sometimes you don't have a label, then human do that. Like I told you guys, the image analysis I discussed last class, right? We had RA train 10,000 pictures, like they label the pictures, 10,000 pictures, 6 months label the pictures, because you need to make sure, because human label has an error, so you need at least the two people to label one picture to make sure if their evaluation are consistent, we use that label. If the two people has different evaluation, we cannot use that label. So use the existing label first as the easiest one. Otherwise, we have to read the picture or text ourselves, and we can build a model to mimic our intelligence of recognizing the text information. And if not, you just use unsupervised, which is grouping. And if you don't want to do all this complicated stuff, using textbook, using Oxford. So these are the options of building up keywords. And I always say start from easy, and don't worry about technology at the beginning. Worry about the research question, and things will become very complicated later on. And should I stop for questions? Keywords frequency. We have a two approach. One is you count the frequency of each keywords, right? This is one thing. Another way is you can get a cosine using, but it doesn't matter much. It's not many people use it. So basically, what I'm saying is, even for keyword, how do you count keywords? There are two ways to count keywords. One is you just count the frequency of the keyword. Another one is you represent the whole text into a vector based on a keyword list, and then use the cosine of that text with your keyword list, and to use that cosine to represent the frequency of keywords. So don't worry about it. I don't want to go too into details about this, but just even count the keywords, you have two options to count keywords, but most of people do the option one. And you guys heard a lot about LDA, so I want to very briefly talk about LDA and So LDA is still belongs to the category of keyword search. So it's unsupervised machine learning, but still keyword search. So there's two ways of LDA. One is supervised, another unsupervised. Most of people use unsupervised, but a lot of people are moving to supervised. So what's the difference between the? So let me just explain the LDA, the what people do. So this is the a breakdown. Question? Okay. So we break down the text into the keyword list. So you see the political blah blah blah. So the size of the dot is the frequency of the keywords. Okay, so actually the same size. Okay. Anyway, I don't know what's happening. Anyway, so supposedly the size of the dot represent the frequency of the keywords, and then so what LDA means? LDA just grouping the similar words together into one group. So for example, I don't know if you can see the screen. So for example, activism, it's semantically similar to politics. So they will group them together, and they will label this group as political topic. So this topic modeling means they will divide. Let's say we have 1,000 words in text, and then they will. So what do you do? The only parameter in LDA is how many topics. So you give the model, say, you believe there are 5 topics. So you give 5 to LDA. LDA will automatically divide the text into 5 topics. And how do they divide the LDA into 5 topics? They based on the frequency. So basically, if the most of the time the activism word will appear close to the politics, and so if the words, so the neighboring words will be more likely to be clustered into one topic. So that's how the LDA works. So basically, they group the words always appear together in text together as one topic. So you give 5 topics to LDA. LDA will group into 5 topics based on the location of the words. Then the assumption is if the words are always together, that means they are semantically close to each other. So they group them together as a. And then many of you maybe question, why do you know it's 5 topics? What if you 10 topics? And then we divide it into 10 groups based on this. And then if you 20, and then you 20. So you guys see there's a JE paper. They say 10K has 75 topics. So they put 75 as the parameter into the model. So you ask me why they put 75? It's totally arbitrary. So arbitrary. So it's totally arbitrary. But what's the right way to do is you should first human read it first, and then you can sense kind of how many topics it is, and then solid way. Normally you should read a small sample of your data, and you can say how many topics in that. And then if you simply believe it's 5, you put a 5. If you put a 10, then you put a 10. So and then you justify, you use the human judgment to do that. There's a statistical way to justify what's the best topic, but that's again very rare used. Just very rare used in even in the computer science. This is rare used. So human judgment will be one way to do. So this is unsupervised, which means just a machine to group everything together. So what is supervised? Supervised is similar to what I said before. What's supervised is you read the text, and then you label this sentence is topic for climate, and this sentence is topic for financial fair value. This sentence is topic for something for intangible assets. Okay, so basically, for the supervised, what you do is you read the text, and for each sentence you define the topics, and then you have the training sample of that, and then you use that training sample as the training sample, and you build a supervised LDA. So LDA, what do is LDA will mimic the way you recognize the climate, recognize the fair value accounting, recognize the intangible assets. So basically, you have to label a fair amount of training data, and then once you have that at sentence level, you can build a model. The model can mimic your intelligence of recognizing each way, and in that sense, they can divide the whole text based on the way you categorize each sentence. So you can see the difference between the two. The first one, you just use the frequency of just neighboring words, clustering them together. The second one is human reading them first, and then we mimic human intelligence of grouping the topics. And then, so going back to Jingwen, right? Jingwen's point, in a human labeling setting, you have performance metrics because you can see how much the machine can mimic the human's labeling process. So let's say human labeling is 100%, right? Categorized. So, and the machine can replicate the human procedure. And you can compare the machine-generated classification, compare that with human classification, and the difference will be defined as either accuracy or recall. So that's that. In that sense, you can do the performance evaluation.
Yeah, because I remember.